So here we have in physics is chapter number 4, number 15. A person stands on a bathroom scale in a motionless elevator. When the elevator begins to move, the scale briefly reads only 0.75 of a person's regular weight. So we have two steps in order to attain the answer. First, we must calculate the acceleration. In calculating the acceleration, we must know the weight, normal force, and scale pushing up on the person. So here is, so let me write it down. Weight, normal force, scale, which is pushing up the person. Since this is an example of motionless physics and we have to compute acceleration, we must use the second law of motion. The second law of motion requires the mass due to gravity. Okay, here's the formula. Summation of F with force, which is the net force minus mass due to gravity, which is equal to mass times acceleration. In order for us to know the answer, we must substitute. So 0.75 mass due to gravity minus mg is equal to ma. And acceleration, we must transfer acceleration to the other side and switch 0.75 to other side, making it negative. So let's say acceleration is negative 0.25 grams, which is equal to negative 0.25 times 9.8 meters per second squared, and the resultant is negative 2.5 meters per second squared. So that's letter A, calculating the acceleration, and for letter B, we must find the direction of the person. Since it is negative, the direction is going down. Okay. Okay. Here we have again in physics is chapter 4, number 23. Arlene is to walk across a high wire strung horizontally between two buildings, 10 meters apart. The sag in the rope when she is at the midpoint is 10 degrees as shown in figure 442. If her mass is 50 kilograms, what is the tension in the rope at this point? So we have the free body diagram showing both sides of equal 10 degrees and the downward force, which is the mass due to gravity. We must first determine and analyze the three forces in it, which is the weight, tension of the force, and on the rope towards the right point of connection. We must also assume the rope is massless. Here's the three forces acting on it. Since the point is not accelerating, we must know that the sum of its forces is 0. Let's consider the vertical forces on that point with up as positive direction. So we have the formula EF is equal to the tensional force sine 10 degrees plus the tensional force sine 10 degrees again minus the mass due to gravity, which is equal to 0. So we have Ft is equal to mg over 2 sine 10.0 degrees is equal to 50.0 kilogram, which is the weight of Arlene, and 9.8 meters per second squared, which is the mass due to gravity, all over 2 sine 10 degrees. we would come up at 1.41 times 10 to the third Newton. That's all. Thank you.